Hello everyone. In today's lecture, we will be discussing the optimal page replacement algorithm. If you would like to learn about other page replacement algorithm, please visit my YouTube channel for more tutorials. Optimal page replacement algorithm that replaces the page that will not be used for a longest period of time in the future. This page replacement algorithm is also called as OPT algorithm, or we can call it as a Belady's optimal algorithm. Optimal page replacement, it gives the minimum possible number of page fault when compared to the other page replacement algorithm, that is FIFO, LRU, MRU. So here the main idea of this optimal page replacement algorithm is looking into the future reference string and replaces the page whose next use is the farthest away. If the page will never be used again, replaces that page immediately. Now we'll go through one example. This is a page reference string and the number of frames are 3. So as per the optimal page replacement algorithm, it's going to replace the furthest future frame, that is to be replaced by the currently requested page. See here, longest period of time which is not using that page to be replaced in the optimal page replacement algorithm. So the number of frames are 3 here. So initially the main memory, all the 3 frames are empty, and the first requested string is 5. So it will search it in the memory. 5 is not available, so 5, that is leading to the page fault. So 5 is leading to the page fault. Next requested page is 0. 0, it will search it in the memory. 0 is not available. So here in optimal page replacement algorithm, it's going to search it in the future like this. So 0 is not available. Two spaces are empty still. So 0 is also producing the page fault. Next we have a string 1. So it will search it in the memory. So only two string 5 and 0 pages are available, and one is requested page is not available in the memory. So again we have one empty space, then one is also producing the next requested bit is 0. So it will search it in the memory. So 0, that page is already available in the memory. That 0 is leads to the page hit. Next requested page string is 2. Again it will search it in the memory. So 501, 2 is not available in the memory. As per the optimal page replacement algorithm, it is going to search it in the future reference. So 2 is a requested bit. So next it was 3. So next we have a 0. 0 is recently a future reference, recent future reference, and again we have a 2, 4, 3, 2, 2, 0, 2, 1. So 1 is again nearest future, and 5 is never present in the future list. So again, so 2 will be replaced by 5. So that 2 is producing the page fault. Next we have a bit 3. So page reference bit 3. So again it will search it in the memory 201. So 3 is not available. So 3 is leading to the page fault only, but it will check it in the future reference. So 0 is the near future reference, and 2 is also near future reference. So and this 3 will be replaced by 1 because this is a very far future reference string. So that 3 will be replaced by 1, that leads to the page fault. Next we have a string 0. So here 0, it will search it in the memory. Yes, 0 is available in the memory, that leads to the page hit. Next we have a 2. Again it will search it in the memory 203. So 2 is available, so that is also leading to the page hit. Next we have a page reference string is 4. It will search it in the memory. So 4 is not available, and the nearest future is 3. Okay, it's 3 is there, and we have a nearest feature 2, and now the furthest feature is 0. So next, that is 0 is replaced by 4 in this. That 4 is also producing the page fault. Next we have a reference page string is 3. It will search it in the memory. Yes, 3 is available in the memory, that leads to the page hit. Next we have a page reference string is 3. It will search again it in the memory. So 3 is also present, so that again leads to the page hit. Next reference page reference string is 2. It will search it in the memory. Yes, 2 is all available. So that is also leading to the page hit. Next we have a reference string is 0. It will search it in the memory. 0 is not present in the memory. Then it will go to the future check. Then 2 is a recent. Okay, it's a recently a future. You can use it. And 4 and 3, so they are not present in the future reference string. You can replace either 4 or 3. Here we are applying the next future string. 4 will be replaced, that is 0 will be replaced by 4. So that is also leading to the page fault. Here the next reference string is 2. It will search again it in the memory. 2 is already present in the memory, so it leads to the page hit. So the next reference string is 1. It will search it in the memory. So 1 is not available. So next it will search it in the future reference. 2 is a near future, and even 0 is also near future. So that is 3 is replaced by 1. So again that leads to the page fault. Next we have a reference string 2. So it will search it in the memory. 2 is already present, that leads to the page hit. Next we have a 7. So it will search it in the memory. So 7 is not available in the memory. So next it will go to search it in the future reference. 0 you can use it future reference, and even 1 you can use it 1 as a future reference. So 2 is not a future reference string. Now 2 is replaced by 7. That is also leading to the page fault. Next we have a page reference string is 0. It will search it in the memory. So 0 is available in the memory. So that leads to the page hit. Next we have a 1 reference string. So again it will search it in the memory. So that also leads to the page hit, because the page reference string 1 is already available in the memory. That is also leading to the page hit. Next reference string we have a 1. It will again search it in the memory. So 1 is available in the memory. That leads to the page hit again. And now we can count the total number of page fault, page hit, and the hit ratio we can calculate, and the fault ratio will also be calculated here. So the total number of page faults are 9, and the total number of page hits are 11, and the hit ratio will be calculated, that is equal to the page hits divided with the total number of reference string. Page hits are 11 divided by 20 references, that is a hit ratio, and the fault ratio will be calculated, that is equal to the page fault is 9. 9 divided by the total number of references are 20. So this is all about the optimal page replacement algorithm, and there are some advantages when compared to the other page replacement algorithms. So actually the optimal page replacement algorithm that produces the lowest possible page faults, this particular algorithm is used as a benchmark to compare the other algorithms. So it has a better performance than FIFO page replacement algorithm, and even from LRU also it has a better performance. And the disadvantages of the optimal page replacement algorithms are that actually it is difficult to implement in a real systems, and requires a knowledge of future page references. Future memory access cannot usually be predicted. So this is all about the advantages and disadvantages of the optimal page replacement. Next we have a comparison of all page replacement algorithms. The same reference string we have taken, and I have solved in a previous my lecture videos. FIFO with the same reference string, even LRU with the same reference string, and MRU with the same reference string, and the number of page frames are 3. Here see, the page fault for a FIFO is 11 and LRU is 12, and the most recently used algorithm is 14, and the optimal is giving a less number of page fault. And the page hit ratio, PO is 9 and the LRU is 8, MRU is 6, and the optimal page replacement algorithm, it is giving 11 page hit, and the page hit ratio will be calculated as per the P4, LRU and MRU and optimal page replacement. By seeing this comparison table, we'll get to know that optimal page replacement algorithm is giving a more better performance than the FIFO and LRU page replacement algorithm. Here, this is a practice example. This is a phase reference string and the number of frames are 3. For this particular example, you have to apply the optimal page replacement algorithm and calculate the hit ratio and the fault ratio for the given practice example and write down your answers in the comment box. Thanks for watching my video. Don't forget to like, share and subscribe my YouTube channel and hit the bell icon so you never miss my upcoming videos. Thank you.